at the tone, the time will be 6 o'clock. Time to start our Hot RFC. All right. So we're actually having a whole lot of fun, more fun than the people next door, despite what it may sound like. For those of you who are remote, we are immediately next door to about 600 of our closest friends who are attending the general reception. For how many of you this is your first Hot RFC that are in the room? Excellent. How many of you it's your first IETF? Even better. Awesome sauce. Okay, well, I'm going to go over some rules, for we shall have rules in this thing. We shall attempt to have rules in the thing. Change the slide. Change it. I did. Okay, we will eventually change the slide. Can I hit the button? Hit the button. Next slide, please. Great. All right, so for those of you who are new, I would like to introduce you to the Note Well. The Note Well is basically going to be something that you will see before each and every working group meeting that you attend this week. And especially for you who have been here for a good long time, how many of you know that it's been revised? Yeah, a lot of people didn't raise your hand. Okay, the Note Well has been revised a bit. So do take just a minute to read through it, know it, love it. It is actually what's going to give us a whole lot of guidance about things like behavior, about things like IP protections, where IP means intellectual property and not internet protocol. So, as they say, please note well the Note Well. There's a lot of various resources that you will find useful for IETF 124 here in Montreal. In fact, you'll find these useful in just about any IETF meeting that you go to, wherever it is in the world, including our agenda, Meet Echo, and other information, and how to get technical assistance. You know, all of these links stay fairly steady from meeting to meeting. So if you do need some guidance, this is a great place to at least get started about what do you need to do to connect, to keep attendance in the room, things like that. If you are interested in, if you're here at Hot RFC because you've got an idea for new work, or you think that eventually you might have ideas for new work and you're not quite sure how to go about it, the IAB has a new work help desk. They've had this before, they're having it again this week. And it is a really useful place to talk to an experienced person, in this case in the IAB, about your work and just get some advice, some direction, some idea of how to progress it from here. Where do you go from here now that you've got a great idea? This is going to be in the registration desk area, both Tuesday and Thursday. And I hope you take a few minutes to swing on by. Often these desks have candy. I'm just saying. Okay, so let's talk about this session. This session is very special. This session is a Lightning Talk series. Lightning Talks that will often be followed by thunderous applause. A Hot RFC is really just getting an idea out there to a group of people. It's to inspire hallway conversations, to see who else might be interested in your pieces of work. And you get 4 minutes. Not 1, not 2, not 3, but 4. 4 minutes. Not 5, 4. We are very strict. Why? Because it entertains me to no end, and because those are the rules. When you hear applause, whether you are presenting remotely or whether you are in the room, you're done. We don't actually do Q&A for any of these. If you want Q&A, keep your eye on the person who did the presenting and chat with them in the hallways. We are using the data tracker for all the slides. Not everybody actually submitted their slides. And so, what is it? The ones that are in the data tracker, number 3, number 6, and number 14, they're actually not presenting because we don't have anything for them to present. Everything, all the slides are basically in our deck up here. So if you are presenting remotely, and we're going to have a lot of remote presenters this time, you'll need to tell us to change the slide for you, and we will take care of that. So remember, practice, applause. It's 4 minutes. Do something. guys, that was awesome. Well done. Thank you. Thank you for making my evening absolutely precious. All right. With that, let's go ahead and just get started right off with Mohammed, who's going to talk about gaps in confidential computing. Mohammed has been here a couple times. He knows how this game is played.
Yeah, thank you very much.
Before we get started, there seems to be a slight issue with the timer where I see the timer counting down, but it was stuck at 4 minutes. So it might just say, 1 minute left or something when as your time's going.
Oh, that's not nearly as fun.
Okay. So I won't see the time here, right?
I just tried it to test it out. So if I start it here.
I see now. Okay.
But
Okay.
It's not. Oh, it's counting.
It's
down
counting.
now.
Yeah,
We're fine.
Never mind.
perfect.
Never mind.
Okay,
Keep going.
Sorry.
Yeah, thanks a lot. I like this forum a lot. I was just telling her that our BOF previously was successful. So this is another attempt to have something different, which is confidential computing. And before that, I want to thank my travel sponsors a lot, Peg Jones, GenXT, Confidential Computing Consortium, and Teleport. Otherwise, you will see me online. Um, the thing is that confidential computing already exists in the IETF, different working groups, or at least there are drafts which are proposed, and some of them are adopted, for example, in RATS. But what is done in RATS is that they are, to a large extent, abstracting away all the hardware details. And they are also abstracting away the transport layer, which means that that can be any protocol. They want to have the attestation of some protocol, whatever that is, that transport layer is out of scope. So the ARM CCA token draft, the endorsements draft, and the TWI attestation, which is the new draft in RATS, which has been proposed and will be presented. Seat working group, which has been now formed. I am an author and I was also the proponent of that. The two drafts that we have talks about the use cases, which include confidential computing, and the expert that will be a transport protocol that will include attestation and that will do attested TLS basically as a starting point. Whimsy has also a few drafts, a couple of those which I have listed here. And the idea here is that Whimsy is not going to talk about or assumes basically the platform as trusted as of the charter right now, that the platform is trusted and confidential computing basically needs that platform part to be untrusted. So there is an inherent conflict there. And finally, like TLS working group, which has a very specific focus on TLS. Of course, it's required a lot, but it has a very specific focus other than confidential computing. And hence there is no working group which is kind of covering all the space that, or an important part of the space that we want to cover. And what I mean by that is basically the attacks. It's actually not working. Can you please move it to next one? Okay, so the problem here is that there are widely exploited attacks like battering ram, T-fail, and wiretap, which have been which we need to take care of somehow, somewhere. And what I propose is there could be a research group which could tackle some of these problems, and that's where I need your help. If it works, yes, good, thank you. I'm seeking collaborators which are knowledgeable in TLS, all the confidential computing. 100% of the solutions use TLS. That's why we need some expertise there. While it will not conflict with TLS, but we need to use TLS in this research group to solve some of the problems. And remote attestation, formal methods, confidential computing, and I'm seeking guidance how to bring this work to IRTF, some proponents, and in the side meeting, I will talk about some of the ideas that I have, some of the problems that need to be addressed urgently. But of course, I'm open to your ideas. What do you think should be done, or what could possibly be done within the scope of the IETF? And finally, I have some pointers to some of the things that you can look at as a starting point. And I would like in the side meetings to take this forward and see what we can do together. Thanks a lot.
Done with 13 seconds. That is well timed. All right. So our next one would have been Eric Riscola, but I don't see him. So we're going to move on to Brian Contario, Brian. Is Brian on? Yes, Brian, you are on. Let us get through Ecker's stuff really quick. Next one. All right, there we go. Let us know when you want to change the slides.
You have to go a little bit farther.
That's Mohit. Oh, did I skip?
Oh,
I skipped one.
You skipped another one?
I did.
Oh,
Oops. Hang on, Brian.
Yep.
I went too
Sure.
far. Mohit goes next.
yeah. Are you here?
Yeah, Mohit's
Okay.
here.
Am I audible?
You are on the screen. Go for it.
All right. Hello, everyone. I'm Mohit from NITK India, and I'll be talking about a new proposal which I have coined as enhancing the efficiency for classic flows with alternative backoff with ECN and L4S. Please go to the next slide. Thank you. So alternative backoff with ECN is an experimental RFC described in RFC 8511. And one of the important things that this particular RFC does is it provides an alternative mechanism for packets that are ECN marked. Based on the original ECN mechanism, which was proposed in RFC 3168, a packet drop signal and an ECN signal would be treated same by the TCP sender. But ABE allows you to have an alternative mechanism because, first of all, ECN marked packets are not actually dropped, and hence the congestion window reduction can be less aggressive than doing it like the way what a packet drop can do. More importantly, this mechanism described in RFC 8511 is a sender side technique only. We do not need any changes on the network side. So for instance, if you can see, if you have a TCP sender with ABE, RFC 8511 recommends you, in case you are using cubic, to reduce your congestion window by 15% if ECN packet is marked. Otherwise, just do a normal reduction like you would do for a packet drop with 30% reduction. So the values mentioned in this slide are all multiplicative factors. And if you are using a Reno TCP sender, you can reduce the congestion window by 15% or 30% if you see an ECN packet is, if a packet is ECN marked, and otherwise just do a normal reduction with 50%. Now this is a typical ABE mechanism. Let's see in the next slide how we want to couple it up with L4S. So L4S has been already described in a few RFCs, and there's also an internet draft on L4S. The most important part is at the bottom part of it, because that is where the classic sender is. And if you take a look at L4S architecture, the scalable TCP sender reduces the congestion window in an adaptive fashion, but a classic TCP sender does not have that flexibility. It has a fixed CWND reduction, irrespective of the fact whether you have an ECN packet or a drop packet. So there's no incentive for the classic TCP senders to actually enable ECN. In the next slide, we will propose to use ABE for the classic flows, which will actually allow multiple options for the TCP sender, particularly the classic sender. We do not touch the scalable TCP sender in this proposal. We want the classic TCP sender to have at least two different options, to have a different reduction factor when ECN is used, and to use a different reduction factor when packet drops are identified. And we have already run some experiments, which we'll discuss in the next slide. So on the next slide, we already have some preliminary results. We just picked up a simple dumbbell topology with one TCP Prague flow and one cubic flow. And Prague flow always has an ECN. Cubic flow has three options. One is no ECN, the second one is with ECN, and the third one is with alternative backoff with ECN. And as you can see in the plots at the bottom on the left-hand side, with no ECN and the center one with ECN, we can see that the sending rate of Prague is more than the sending rate of cubic. But by using ABE, we can see that both the sending rates are more or less the same. We do have Linux and NS3 implementations of ABE. We are looking for collaborators who can help us test ABE in L4S in real deployments, particularly with respect to fairness, queue delay. That's it. Thank you.
Well done. Well done. All right, Brian, for reals this time.
Okay, great. Hi, I'm Brian Contario. I'm with Silent Sector, and I'm here to talk about the internet draft to add secure enrollment to time-based one-time passwords, one of the most common forms of multi-factor authentication. Next slide. The QR codes we've been using for years in our MFA applications have a problem. The secret key is included in the QR code unencrypted, and it never expires. The secret key, in addition, the QR code also contains the username and application name, giving attackers everything they need to target a system except for the password. Next slide. Despite good intentions, administrators have introduced unintended risks over the years. It's become a common practice for some admins that are enrolling remote users to send them a copy of the QR code via email, text message, and other electronic means, where the secret key will quietly live indefinitely. Some admins have even printed out the QR codes as backups that can later be discovered. Attackers can find those QR codes in data dumps from breaches and discarded papers, and then combine them with compromised credential data sets to greatly increase their chances of successful authentication. Next slide. The solution we propose is to replace the secret key in the QR code with a single-use HTTPS URL that can be used by the Authenticator app to get the secret key directly from the server. This process is fail-safe because if an attacker accesses the URL first, the URL will already be redeemed and the real user will get an error response that will prompt them to repeat the operation using a new QR code and secret key until they get there first. Next slide. From the user perspective, there is no change to the workflow. The user still scans the QR code, but now the Authenticator app will make a background HTTPS connection to the server to get a data string that is identical in format to the content of the legacy QR code. Then, as before, the user still types in a new one-time code to verify that everything worked. Next slide. This simple improvement ensures confidentiality of the MFA secret key, since once the new QR code is redeemed or expires, it's useless. The changes to both the Authenticator app and the server are minor, since in the end, they're both still handling the same enrollment data that was in the legacy QR code. All of this boils down to sending the contents of the original enrollment data securely over HTTPS, using simple technical controls to ensure that it is transmitted one time only. Next slide. Lastly, the background communication between the Authenticator app and the server provides an opportunity to make the MFA login process more helpful. Once adopted, the login page can prompt the user with a reminder of which Authenticator app and device to get the 6-digit code from. Next slide. So if you're interested in contributing comments, code, or collaboration to help move this effort forward, please check the Security Area Advisory Group mailing list or send me a direct chat right here in the meeting. Thank you.
Fantastic. Thank you. So just as a quick aside, I've noticed that my timer in Meet Echo and the timer on the screen here in the room are different. So I don't know what actual remote participants are seeing. We're going to have a character building experience this week, I think, but it's all good. Okay, so we have, next one is another remote presenter. That's Yunfei Zhang. Problem statements and requirements for real virtual agent protocol. Go for it.
Thank you, Liz. Can you hear me?
We can hear you.
Okay, excellent. Good evening, everyone. And this is a new initiated proposal called RVP, Real Virtual Agent Protocol. It has been submitted to IETF, and it's a protocol initiative of to do communication for embodied intelligence in physical digital continuums. Next slide. So this is an overview. The RVP unified physical and digital agent communication supporting hierarchical, non-peer-to-peer, heterogeneous, and partially centralized communication and coordination between physical entities like robots, IoT devices, manufactured system and agents, and digital agents like AI models, systems, software agents, and virtual twins. And through RVP, it will achieve the real-time physical data loop for online learning. For we know that the the data in the on the internet for training has been running out, and it needs the real-time physical data to supply for supplement to do their online training. And through that to form their embodied intelligence network. And there are three key points for RVP. The first is the unified composite identity management. The second is the physical social production relationship, graph-based coordination, and third is the physical constraint integration. And next slide, please. Okay, let's review the current protocols we are the industry has. The MCP and A2A are gaining much attention in industry, and MCP provides the interface between agent and tool and resources to avoid the ecological fragments. And A2A is a protocol between the agents to form the multi-agent collaborations. Next slide. However, when we face the physical world, there are three unique features while MCP and A2A are not addressing. The first is there are different forms of agents. There are digital agents, which MCP and A2A are mainly addressing, but there are also the physical ones. And it needs to do the real virtual mapping and convergence. And second, that in the physical world, the physical, social, and production relationship are not peer-to-peer, and it's more complex. And we have different roles, different types, and different levels of agents. And third, that there are the third point is that there are cross-domain and heterogeneous communication phase. So in the left figure, besides the MCP and A2A, we have RVP to connect to convey the information of the physical world, and through the three protocols to link the physical world and the digital world into the embodied intelligence network. Next slide. Okay, this is a problem in current protocols for identity fragmentation and lack of the physical social relations mapping and lack of the physical constraints and the efficient registration and effective discovery and the real-time data input. So requirements are open for. Sorry, I'm not.
But that's all right. You all have the ideas. The slides are available online as well. Reach out to him if you've got some thoughts on the matter. Thank you so much for presenting.
Okay, thank you.
All right. Now we have someone in the room. Oh my gosh. Michael, come talk to us about real-world cybersecurity risks and defenses. Here's your pink line. There is a, where's the thing? Oh, you don't need the clicker. Okay.
Sorry. Hi everyone, my name is Michael. I'm from the UK National Cybersecurity Centre. I just wanted to take this opportunity to flag that we're holding a side meeting on Tuesday at 11:45 to talk about real-world cybersecurity risks and defences. So at the UK NCSC, we work with loads of industry customers from critical national infrastructure who are worrying about cyber attacks from advanced threats down to the small businesses and individuals worrying about less sophisticated cyber attacks, but just as impactful. We also try and look ahead at emerging and future threats to security, and that's very much the motivation for holding this side meeting. We really would love a wide view. We think IETF has lots of expertise in security and from operational backgrounds, and we really want to hold a discussion on current and emerging threats. So part of our function is an incident management function where we go into companies who have been affected by cyber attack. And so we can bring some case studies of some of the threats that we see, but we'd really like a collaborative discussion of some of the threats and security issues that you're worried about as well, and have that kind of collaborative knowledge sharing upskilling. So yeah, thank you. It's 11:45 on Tuesday. If you have specific ideas for topics you want to discuss, we do have some time in the agenda, so please do reach out. But otherwise, yeah, come along and join the discussion. Thank you.
Zipping right along. Next, we are back to remote presentation. Guanming, you're talking about AI native network operations. There you
Hello,
go.
can you hear me?
We can hear you. Thank you.
Okay. So hello everyone. I'm Guanming and I'm from Harvard Technologies. So today my topic is AI native network operations, scenario protocols, and extensions. And this is so let's switch to the next slide. Okay. Today my talk roadmap includes 4 parts. And basically, they are all about some the AI network scenarios and some other works on the protocols. So, as we all know, recently some AI-related protocols such as MCP and A2A is becoming more and more popular recently. So, the first thing I want to talk about is the network AI scenarios, and specifically, I want to explain about what capabilities must protocols offer. And and the second part of the talk roadmap is uh, for some traditional protocols like the netconf, uh, and I want to analyze why the netconf falls short when they are applied in some network AI scenarios, and and I want to and I want to turn to the reason of why we want to use MCP and A2A. And the third part is the gaps remain when we use the MCP and A2A, because when we switch to the new protocols like MCP and A2A, it doesn't mean that we can use them directly. So we still have to fix and modify the MCP and A2A protocols. And the final part is our extensions. It is the network, for example, for some network aware MCP addictions, and then we will propose in this part. And so, since this is the hot RFC, so maybe I wouldn't expand the content in a very detailed way. So let's switch to the next slide. Okay, and I will just briefly introduce them. For example, the case for I have proposed some draft about some the cases for the MCP and A2A for some AI native network operations. Specifically, I have proposed some use cases for the measurement, network measurement, and troubleshooting, and you can refer to the IETF draft on our slide on the below part of here. And let's switch to the next slide. Okay. Uh, and this slide is about why netconf is not enough, and I have showed some basic information about the netconf, what it lacks when it is used in some AI native scenarios. And the conclusion is netconf still remains the configuration authority, but MCP and A2A are essential for AI-driven, multi-agent, and agile operations. And you can also refer to the IETF draft on the slide. And let's switch to the next slide. Okay. And the third part is the gaps in MCP and A2A for network use. Specifically, we focus on 5 parts. Okay, thank you very much. Okay, could you please
Thank
and
you.
yeah,
Hey,
my
don't
meeting
worry,
is will
the
be on
slides
the,
are all online. For folks that want more information, including where to reach out, what drafts to look at, please go there. And there's also the chat here in MeetEcho, which I'm sure you have all logged into. Right? Am I right? Right. Okay. Moving on. We are moving up next to Mick Norden, talking about Open Cloud Mesh.
Yes, hello. So we can go directly to the next slide. We are a recently chartered working group, and I'll be there from tomorrow, so you can come talk to me. Now I wanted to show you what OCM, Open Cloud Mesh, is from an end user's perspective. So you know what you will be collaborating with us on, hopefully. So we're going to have to go quick because there's no video, so 30 frames per second. We can take next slide. So this is the way of sending a link format invitation in OCM. So this is the Nextcloud interface of Surf, my colleague in Amsterdam, Anton. So next slide. He enters my email and he generates this invite. Next slide. And that makes me able to click on a link in my email client. Next slide. And I can come to a where are you from page and select my OCM provider. Next slide. And I get a pop-up asking if I want to exchange contact information. Next slide. And say his contacts are saved now into my address book, and same thing for him. Next slide. This is the EU EOSC node built on OwnCloud. So previously we had Nextcloud. This is a different interface on how to generate an invite, but it still works the same way. Next slide. This time we send the invite string over matrix in this case. Next slide. And he can copy it and go to the next slide. And use an interface in this case Nextcloud to accept the invite. So next slide. Yes, and the same thing, saved it to the address book. Next slide. So what you can do then when you have exchanged contact information, so really it's a way to use out-of-band communication and still allow servers to know where to find each other. And using this information, we can share files between us. So this is now Cernbox, a third software, and it will send a share now to the EU EOSC node. Okay, next slide. And here it is available, next slide, in the interface of the other software, and you can see the file and edit it, and it will show up on both places. And the authentication is done with Bearer token in this case and WebDAV, but the protocol is agnostic to the underlying transport. So next slide. And this is done through a variety of metadata exchanges. So for instance, discovery here, and next slide. And this is another type of discovery that's happened for the federation itself. So next slide. And please come and talk to us and join our mailing list, and thank you.
Oh, that was well timed. Well timed. Good job. Okay, we are back to some in-person people now, hopefully. Guilin Wang, you here? Yes, you are. Excellent. Enjoy your pink X. There you go.
Thank you. Okay, so my talk is about a new theory on PQ migration. PQ means post-quantum migration. Okay, next one.
You can use.
Okay. Okay, yeah. So actually, hybrid key exchange are already widely accepted. So this talk will just focus on the hybrid signatures. Basically, two issues: why hybrid signature actually is valuable, and how about the performance and the complexity. Yeah, the purpose of this one is I would like to offer a personal viewpoint for the value of hybrid signatures in PQ migration, and then invoke further consideration or even discussions on this topic. It's not complex in my point and understandable for everyone. Yeah, the background is why I call this theory is mainly about some quantitative analysis with simple probability reasoning based on the recent discussion in several mailing lists. Okay, next one. Okay, so a typical question is like this one. So why we need hybrid signatures? If we just know quantum computer is coming at a point, in that case, just before that time, we use traditional. After that, we use PQ algorithms. But the question is not that simple. The main reason is that we don't exactly know when a quantum computer is available. Most likely, it will be available 2035 or something or after. But the question is that, like from 2030 to 2035, what we can do? Basically, we have three possible choices. So in this one, in my talk, I would like to give a quantitative analysis on the three possible choices. But before that, of course, I need to do some assumptions. My assumption is that for a traditional signature scheme, we can say its risk is about 1/1000, and a PQ signature, maybe it's not so mature. So we can think, we can assume its risk maybe 1%, 1%. Yeah. So another thing is that we need to suppose in this period, a quantum computer is how likely it is available. So according to the opinion-based estimate from Professor Moscow, yeah, we can do a simple average. So we can say, yeah, maybe a quantum computer will be available like 18%. So finally, we do some total risk analysis. Yeah, it's just a weighted risk against the classic and the complex attacks. Okay, next one. Yeah, so we can say three choices. The first, we just transfer in this period, is the uncertain period, we use traditional signature. In that case, we have 18% risk. And then second choice, we just move to the post-quantum PQ signature. In that case, 1% risk. And the last one, if we use the hybrid signature, the risk will be reduced to 0.18%. So this means choice 3 actually can reduce the risk 5 times even than the choice 2. Okay, next one. So about the performance and complexity, we can say it's not too much because the size is just intended about 10%. And the complexity just calculated to signature, not too much. Okay, last one. Yeah, so this talk just show, based on quantitative analysis, we can show it is valuable to use a hybrid signature. So we would like to seek more discussion and more thoughts about this topic, more about the policy, something like this. I don't say my reasoning is definitely right, including like the assumptions. So we can talk together. Thank you.
Well done. Thank you. All right, Nick. You can use the clicker, or you can tell us to change slides, whichever you like.
Thanks. Hello, everybody. So I'm here to talk about Armor. This is a new group, not a working group, not a research group, but it's an email list, and it's going to be focused on. Okay, jumping ahead. All right, so the focus of this mailing list is end-to-end connectivity. So there's a lot of instances in which encrypted connections over the internet are being changed, interfered with, or looked at by on-path devices. There hasn't necessarily been a group within the IRTF to look at this from a research side, or from the IETF to tackle this directly. There's been adjacent groups who are working on various things such as measurement at MapRG, HRPC's policy human rights, PAIR-G's privacy. All of these really tie into the idea of end-to-end connectivity that's resilient. So we founded a new mailing list. So if you can go onto the armor at irtf.org, please join. So here's the broad vision here is it's a cross-community space for empirical studies, protocol enhancements, and deployment lessons. So things like best practices, measurement studies on the deployment of different protocols, all focused around this armor topic. And so, last slide.
Okay. There, whoops.
Oops.
There you go.
Okay. All right. So we're looking to connect a lot of different people because this topic affects anybody using the internet. So we are having side meeting tomorrow at Duluth, which is, I believe, on this floor at 7 p.m. So after a big, long, busy day, there's going to be some great presentations by researchers who have looked at various aspects of these problems. And we'll have a discussion as to where we can take this from here, if we want to take it beyond a mailing list. That's it.
Thank you, Nick. Awesome sauce. All right, 4 more left. A stretch break, really quick. Okay, Lorenzo, you're up.
Is this working?
Sometimes.
Let's try it. Okay, it's a pleasure to be here at IETF. My sponsor is the Brazilian Committee on Internet, and I'm assistant professor in Aeronautics Institute of Technology. I'm talking about the research we are doing at there, where we're using Wi-Fi CSI to identify, to make a proof of presence. Let's try it. Okay. The problem statement is the lack of interoperable proximity evidence. Think about a story about Alice and Bob and Eve. Alice will use his credit card to pay Bob, and he lost his credit card, and Eve get this credit card and try to impersonate that financial transaction. So we can identify that that card, it's not in belonging of the owner of that card. Okay, so we can use Wi-Fi. We can observe Wi-Fi is everywhere, and also Wi-Fi sensing is out there. And we can, in the future, has no instrumentation or bare minimum instrumentation. What is HandPass? HandPass is a system that we use to identify a person, authenticate a person using his palm hand. Okay, so we have the Wi-Fi. Oops, next slide, please. So from the Wi-Fi, we got a tensor. With this tensor, we have it's working now. We have the interference that a body induced in the Wi-Fi. We put that on a machine learning workflow, and so we can authenticate or not authenticate a person. Bringing this to the context of IETF, we see no specifications in the IETF defines physical proximity has a attestation evidence. We see a lot of mechanisms to that. On the other hand, we also see HO2 11BF, but it not have mechanisms to attest the presence of a person or device. So we are bridging this gap here. We thought about making a NEAT or something like that for a token for attest the proximity. A new draft, a new, who knows, informational RFC or buffer feathers, who knows, but to find a minimal interpretable indicators of presence that we can use to make the proof of a presence, attestation of a presence, you see, for example, in a device or a person. And also keep this sensor agnostic. We can use with Wi-Fi CSI because Wi-Fi is everywhere, as I said. But for example, ultra wideband, Bluetooth low energy, and even acoustic sensors, acoustic you see acoustic approach for that. Okay, so bridging in pragmatic way, bridging the gap on IEEE sensing with IETF attestations and identity frameworks. Why it matters? So we can put that into the systems and make attestation of this. Let's suppose drones, let's suppose people, presence of people. Okay, so as far as I know, there are no conflicts, and we have a preprint and future the hand pass, and that's it.
Well done. Excellent. All right, we are back to one more remote presenter with the best opening slide we've had so far. I'm just saying. Giulio, please.
Hey everybody, thanks Liz. I'm Giulio, and with some friends in Italy, we are working to bring up a small non-profit ISP. And since we are non-profit, we don't really have to pursue commercial interests. We don't have to compete on speed or prices. And so we were wondering what's the best technical stack that we can implement so we can protect the security and privacy of our users. And next slide, please. So when you have an ISP in Italy, but also probably in other countries, you have a lot of legal obligations that are not the most pleasant to carry out. So we have to log all connections and IP addresses assignments and keep those logs for, I think, 8 years. Then we have to intercept traffic when a request comes. That's not very common, but it still happens. And then we have to enforce DNS-based blocking, and that's very big list, like thousands of entries. And then enforce IP-based blocking, basically no routing things. And then we have a new thing in Italy that's called Piracy Shield that basically mandates to block IP addresses within 30 minutes of notifications. And those notifications come from a centralized private system where certain right holders can just upload lists with no judicial oversight or no particular checks. And this has backfired multiple times where Cloudflare was blocked in Italy or Google Drive or stuff like that. Next slide, please. So the architecture of an ISP kind of looks like the same as 30 years ago. There's customer equipment that's then connected to either a passive optical network in case of fiber or is transmitted over radio. And then there's a switch that is eventually backhauled back to a router that connects to the upstream. And next slide, please. And when you are a small ISP, it's pretty clear that you can't run your own fiber, like you can't dig and do that with limited budget. But you can do is that you can rent part of the infrastructure, and then you can choose the equipment you want for the subscribers, and also you control the edge routers and the upstream that you choose. And while generally use dedicated networking equipment, in our context, we don't have any particular bandwidth requirements. So we can actually use general purpose machines and explore into attestation, verification, and other aspects. Next slide, please. So we all know where the blocking and interception has to happen, and it has to happen on our last hop before we go to the upstreams. And we have to apply that, like it's legally mandated. And we would love to be able to challenge that and say, hey, you know, we would really love to log IP addresses, but maybe that's encrypted, that's masked, or we would really like to be able to experiment and have technical defenses against all these mandatory constraints. And next slide, please. And basically, we're just looking for people that are interested into experimenting with our infrastructure. We have end-to-end choices where we can literally choose what goes to the subscriber home. We can choose what runs on our routers. We can choose many things. And so we would like if the community could help us see what we can do to improve the status quo, especially since we're doing this for fun. Thank you.
All right, Roland, I believe you're up next with Kira. Sometimes.
Okay, hi, I'm Roland. I'm talking about Kira, which promises scalable zero-touch routing. And addresses an often overlooked problem, namely control plane connectivity. You may have heard of that famous Facebook outage that happened in October 2021, where they misconfigured their BGP routers and locked themselves out of their control plane. They need to send engineers on site, and they couldn't get into the data center because authentication or access control of the data center was offline. And also Google, in a recent paper, said that the control plane was the root cause of more than 50% of the cases when operating their B4WAN. So the control plane is really essential for providing also the services in the data plane. And since networks tend to get more complex, the idea is maybe to tackle this by simplification. No, oh, sorry, take some time. Okay, so the objective of Kira is basically that you never lose control over your network infrastructure by providing resilient autonomous control plane connectivity. So the approach features scalability, so it's scalable to hundreds of thousands of nodes in a single domain. So we actually simulated 500,000 nodes. So it's zero touch, so it doesn't require any configuration. So that's why you can't misconfigure anything and shoot yourself in the foot. And it's also able to run in many different topologies, be it dense data center topologies or sparse WAN topologies. No, it doesn't matter. Also supports mobility because it's an ID-based routing protocol. And therefore also supports multi-homing as well as domain contexts here. It also brings add-on services like a very efficient topology discovery scheme, and more importantly, also a distributed key value store that enables you to let services rendezvous, and so you can register names and also look up the names in a distributed manner. No, next slide doesn't work. Yeah, no. Okay. So why am I here? So the main benefit of Kira is made if it's available in every network device, and therefore it needs to be an IETF standard. There's an internet draft. Please comment. So basically, the routing working group list would be suitable for that. We have running codes that provide zero-touch IPv6 connectivity, so no special forwarding requirements. So we are looking for operators, collaborations, and also early implementers. There will be a public site meeting on Thursday, 2:45 in McGill, and there will be some introduction and also Q&A and whatever you want to discuss. I'm here the whole week, so yeah, please come and see me. That's it.
Okay. All right. Last but definitely not least, Andrew, come talk to us about Parsep? Parcep? How would you pronounce that? Parsep.
Hi, everyone. Good evening. I'm going to talk to you about a proposal to develop a network protocol for parental controls.
Next slide.
Yeah. So just probably stating the obvious, parental controls are really helpful to allow families to manage how their children access devices and services. And there's a lot of them, whether it's at the ecosystem level, device level, applications, networks, platforms on the internet. There's a plethora of options. The issue is that they largely don't talk to each other, don't interoperate. And so from the perspective of parents, it's a huge problem, because if you want to have a safe environment for your children, you've got to navigate all of those. The language that used is pretty horrible. In the examples of the same terminology meaning different things in the different ecosystems, or different terminology being used to mean the same things. So even for highly motivated parents, it's very, very difficult to actually get this to work effectively and consistently across the different platforms. Next slide, please. So what we're proposing is to pull together people that are interested to actually work on actually designing a protocol to allow interworking between the different parental control systems. So that you can actually communicate between them and carry across the settings between the different environments. If you like, sort of those of you that are familiar with Mimi for the instant messaging sort of interworking, effectively to do something like that for parental controls. Next slide, please. The reason why we think we need to do this, apart from to make it better for parents and safer for children, is there are external pressures actually requiring us as a community, the sector, to do better in this space, whether it's in the form of regulations or legislation at national level, or indeed from the UN, that there are a lot of concerns about the harms being inflicted on children, and the issues seem to be getting worse. Next slide, please. And if we don't do anything, obviously there's a risk of the continuation and acceleration of that harm, but also an impatience from the wider world to actually force action upon us, whether it's in terms of mandatory age gating of access to different services, and or a lot of momentum building about the so-called smartphone-free childhood. So if we do nothing, then there could be external changes forced by an impatient sort of user base, if you like, around the world. Next slide, please. So very simply, if you think this is a useful problem to try and solve, we've got a side meeting in Duluth on Tuesday at 7 p.m. local time. So come along, talk to us, and let's get our heads together and see sort of whether and how we could actually put a proposal together to solve the problem. And if you can't make that, next slide, last slide, there's my email address, and one of my sort of collaborators, David, who I'm not sure if he's made it here yet, but you can just mail us and join the conversation that way if you can't make it to Duluth on Tuesday. Thank you very much.
All right, I'll have you know it's a high-stress operation trying to do all of these things in 4 minutes. So one more quick round of applause to all of the presenters today. You did great. And with that, go forth, conquer the world, do good things, and don't forget to get some sleep. Kitties. I saw it before, and then flash immediately to 2 minutes to 8:28. I was it did flash before, and it was weird. 2 minutes and 28 seconds. I hit reload. I don't know what happened either, but that was very cool. Lucy, how are you? So, so don't forget that the oxygen in the airport are completely absolutely. So she's a bit tired.
Then see you. Yeah, I'm here the whole week. Yeah, Seattle.